So, good morning, dear students. This is our third lecture from the series of lectures which are arranged for BSc first year, semester 1, and today's topic is elasticity. So, in previous lecture, we have finished the topic gravitation. So, today we will see chapter 3 elasticity. So before starting this chapter, I will like to ask some questions to you. So what is elasticity? First point is, or first question is, what is elasticity? Dear student, you might have been studied in 12th science the topic elasticity, in which you also studied stress, then after strain, Hooke's law. So you already studied these points in your syllabus of 12th science. So you might have been aware about the basic concepts, that is stress, strain, Hooke's law. So before starting all the concepts, I will tell you one example. So first of all, tell me which is more elastic, steel or rubber? This is my first question. What is elasticity? My second question is, which is more elastic? Which is more elastic? Elastic, either rubber or steel. Rubber or steel. So most of the student will feel that rubber is more elastic than steel. Rubber is more elastic than steel, because student makes mistake by thinking that rubber can be stretched more than the steel. But this is completely opposite to each other. Here steel is more elastic. Steel is more elastic than rubber. So we'll see one by one. So elasticity is the property or physical property of the body or material by which an opposing force acts on body when body is deformed from its original size and shape. So what is the elasticity? It is the physical property or property of the body or material by which body try to regain its original position when it is stretched by deforming forces. Or I can say, for example, I have suppose say rubber. Suppose this is the piece of rubber. So I will elaborate this by taking an example of the piece of rubber. So you will get more acquainted about what is the property elasticity. Now suppose I have a rubber, piece of rubber. I have suppose this is the piece of rubber. This is the piece of rubber. And this is the original length, capital L is the original length of rubber. Now what I will do, I will stretch this rubber by applying force. By applying force. So this force is called as the deforming force. This force is called as the deforming force. Always remember. Why deforming? Deform means to change the original size and shape. Deform कशासाठी शब्द वापरतो आपण? To deform. Form, opposite of form, deform. Deform means what? To change the size and shape of the original object by applying force. This is called as the deforming force. So what I have done here, I have applied force, and because of this force, what will happen? Suppose this is the first step, this is the second step. So rubber will be stretched. Rubber will be stretched. and this is the new dimension and this is the original dimension. This is the original dimension. So because of the force, rubber is stretched. Now what happened? This rubber has its inherent tendency to bring back this piece which is stretched by deforming force. So what rubber tries? Rubber tries to bring this deformed piece to its original position. Means what? This rubber try to bring this elongated length to its original length, capital L. Now this tendency of rubber to bring its stretched body to its original position is called as the elasticity. Means what? Elasticity is nothing but the property, physical property of the material or body to bring its stretched body to its original position. Means what here? Rubber has done work against deforming force. So what rubber has done? Rubber has done work on deforming force. On deforming force. Now it is very basic question. Rubber tries to bring its stretched body to its original position. Of course, this is possible only there is an internal force. कधी शक्य आहे हे? ज्यावेळेस रबर एक इंटरनल फोर्स एक्झर्ट करणार की जो फोर्स will work against this deforming force. So this internal force is called as internal elastic force. याला काय म्हणायचं? या फोर्सला काय म्हणतात? This force is called as internal elastic force. Internal elastic force. This is called as internal elastic force. Very simple. We have seen two forces. First is the deforming force and second is internal elastic force. Internal elastic force. So understood up to this step? So elasticity is the physical property of the body or material by which body comes to its original position by applying internal force against the external deforming force. So this is called as the elasticity. Now look here, this is the internal elastic force. So this force plays important role. This force plays important role in stress and strain. In stress and strain. Now a possibility is there when external deforming force is greater than internal elastic force, what will happen? If external deforming force is greater than internal elastic force, what will happen? This body will elongate. This body will elongate, and if this is very much greater than this body will permanently elongate. Now suppose this is the original length, and if this capital F is very much greater than this internal elastic force, what will happen? This body will be permanently deformed. ती बॉडी काय होणार? परमनंटली त्या पोझिशनला तशीच राहणार. कारण काय? जो आपण एक्सटर्नल फोर्स अप्लाय केलेला आहे त्याची मॅग्निट्यूड ही इंटरनल इलास्टिक फोर्स पेक्षा खूप जास्त आहे. This is very much greater than this, then we can say that this is perfectly plastic body or it is perfectly elongated body. Now this internal elastic force per unit area is called as the stress. So understood this concept? So now we have started to the topic stress and strain. So this internal elastic force per unit area is called as stress. Now, stress is classified under three types. First is the longitudinal stress, or it is also called as the tensile stress. Longitudinal or tensile stress. Now, in this stress, when there is a change in length of body by deforming force, now this is the capital L is the original length. By applying deforming force, what happens? This is capital F. By applying deforming force, there is change in the length of the body by amount small l. So this is after deformation. So in tensile stress, when this deforming force causes change in length, then it is called as the longitudinal or tensile stress. So how we will define this? When deforming force changes length of body, then it is called as tensile stress or longitudinal stress. Now, in this second classification is volume stress. Sometimes what happens? There is change in volume of the body by application of deforming force. So we will change the definition. When deforming forces changes the volume of the body, it is called as the volume stress. And third type, shearing stress, or it is also called as the shear. So in this, when deforming forces displaces body from its original position, suppose this is the body and deforming force is applied to the body. Now suppose A, B, C, D is the original position of the body. By applying this deforming force, there may be displacement of body from its original position. So I will say this is A dash, this is C dash. Now this is the example of shearing stress. So it is given by A dash upon AB or C dash upon CD. So dear students, today we have finished definition of elasticity. Then we came across to the deforming force, internal shearing force, and we have seen one by one types of stress, definition of stress, and then three types of stress. So I think you have understood this topic. It's very simple, and in next lecture we will continue for next concept, that is strain. So thank you all. Thank you.